Hey everyone, and welcome. Today, we're diving deep into one of the most crucial topics in Form 4 agriculture, soil science. We're going to uncover the story of the unsung hero that's literally right under our feet.
I want you to think about the last thing you ate. Seriously. Maybe it was rice, some vegetables, a piece of fruit. Have you ever just stopped for a second and asked yourself, where does all of this really come from?
Well, it all starts with the very foundation of life, the plants we grow. From the tiniest little herb to the tallest tree, that's the source. But what's the source for the plants themselves?
You got it. It all begins with the true unsung hero of our entire food system, the soil. It's so easy to overlook, isn't it? But without it, life as we know it, well, it just wouldn't be possible. So let's get to know this hero a little better.
Okay, so to really get a handle on soil, you first have to understand its personality. And in soil science, that personality is all about its basic physical properties.
So, this table breaks down the three main soil personalities. On one end of the spectrum, you've got clay. Its particles are super fine and packed together, which is great for holding on to water and nutrients, but it means drainage is pretty bad. Then you have the complete opposite, sand. The particles are bigger and looser, so water and nutrients just slip right through. And right in that sweet spot, the one that's just perfect for farming, that's loam. It's the ideal balance of everything.
The scientific name for this mix of particles is soil texture. It's really just the percentage of sand, silt, and clay in a soil sample. And it's not just a fancy term, it's a super precise classification that tells a farmer everything they need to know about what that soil is capable of.
And this is the tool the pros use. It's called the soil texture triangle. It might look a little complicated, but it's pretty straightforward. By plotting the percentage of clay, silt, and sand, you can pinpoint the exact type of soil you're dealing with, whether it's a sandy clay, a silty loam, or something else entirely. Honestly, knowing how to use this is a core skill in agriculture.
But a soil's personality isn't just about its physical texture. We also have to understand its chemistry, or what you could call its mood. This mood is measured by something called pH, and it is absolutely critical for plant health.
So, what exactly is soil pH? Simply put, it's a measurement of how acidic or alkaline the soil is. It might just be one number, but believe me, it tells a really complex story about everything happening just beneath the surface.
This scale here shows you the range. Anything below 7 is acidic, 7 is perfectly neutral, and above 7 is alkaline. Most plants have a pH sweet spot where they grow best, and that's usually somewhere between 5.5 and 7. If the soil's mood gets too acidic or too alkaline, the plants just won't be happy. So why is this one little number such a big deal? Well, first up is nutrient availability. If the pH is off, essential nutrients can get locked up in the soil, meaning the plant's roots can't absorb them. It also affects all the good microbes that help plants grow. And finally, the wrong pH can basically roll out the red carpet for plant diseases. Okay, so we know how to identify a soil's type and check its mood. Now, let's get practical. How do we actually take care of our hero? How do we conserve and improve the soil we have? This brings us to the really crucial question. What can we actually do? If our soil is too packed down, too acidic, or just doesn't have enough nutrients, what's the fix?
In farming, there are 5 key methods. Tillage is basically loosening up compacted soil. Liming means adding lime to raise the pH if your soil is too acidic. Fertilization, well, that's for adding nutrients. And finally, you have irrigation and drainage. That's all about water management. You add water when it's dry and get rid of it when there's too much. Each method tackles a very specific problem.
When it comes to fertilizing, you've basically got 2 main choices, organic or chemical. Organic fertilizers are amazing for improving the soil's structure and its ability to hold water over the long haul. Chemical fertilizers, on the other hand, are fast-acting and can deliver specific nutrients right when the plant needs them. The best strategy? It's often a smart mix of both.
And to really understand fertilizers, you've got to understand the numbers on the bag. Here's the classic example. Let's say you have a 50-kilogram bag of urea fertilizer, and it's labeled 46% nitrogen. How much actual nitrogen is in there? It's simple math. You take 46% of 50 kilograms, and you get your answer, 23 kilograms of pure nitrogen. Knowing how to do this little calculation is super important, not just for your exams, but for managing a real farm effectively.
All right, let's zoom out from all the technical details for a second and look at the big picture. Why does all this stuff about soil science actually matter? Not just for you, but for all of our futures.
This quote from a University Malaysia thesis really says it all. Agriculture students are the future pillar of the agricultural field. Think about that. What you're learning right now isn't just about passing a test. You're training for an incredibly important role in our society.
So, if there's one thing to take away from all this, it's this. Understanding soil is the absolute first step to ensuring food security and building a sustainable future for our planet. Everything, literally everything, starts from the ground up. The soil gives us life. It feeds us, it supports us, it keeps us going. So the final question I want to leave you with is this. How can we, with our knowledge and our actions, start to give back? Thanks for joining me for this breakdown.